So these notes cover operations with polynomials. So to start, we have this idea of simplifying a monomial, which is a single term of a polynomial. A monomial expression is in simplified form when all of these things are true. You can't have exponents on top of other exponents. Every base or variable only appears once. Fractions are simplified, and there are no negative exponents. So we'll use the laws of exponents that we worked on in class today. So to start, we have simplify xy squared, and then this exponent, this 3, should really be on top. So it's xy. So only the y is squared, and then that whole parentheses is being raised to the third power, and then times xy to the negative third power. So to simplify this, we'll look at each little section of it separately. Xy squared then to the third power means that we have x to the third, and then y squared to the third power. We multiply the exponents because it's a power raised to another power, and that gives us y to the sixth power. Now remember, a negative exponent is saying that we're going to have 1 divided by the positive of that. So really that's 1 divided by x to the positive 3 and then y to the positive 3. So now remember, if we're multiplying fractions or rational expressions, this bottom denominator is a 1. So this can be written as x to the third times y to the sixth divided by x to the third times y to the third. And then we can use the subtraction law, or the quotient of powers. So x to the third divided by x to the third, intuitively that's going to equal 1, and in fact that is x to the power of 3 minus 3. And then y to the power of 6 minus 3. So this is x to the power of 0 times y to the third. But we know that anything raised to the power of 0 is 1, which makes sense if you look at it here because it's a number divided by itself. So this is just y to the third power. So moving on to this second example. I think the first thing we should take care of here is all the negative exponents. So in this first set of parentheses, only the a is being raised to the negative 2. So really that is 2 over a squared. Second part we can leave alone. 3a cubed times b squared. And the last one is 1 over c squared. So looking at it now, all the numerators would come out to, notice we have a 2 times 3, so that's going to be a 6. And then a to the third, b squared, all divided by a squared times c squared. And from here, the only thing we can simplify is a to the third minus a squared right here. That's going to come out to a to the first power in the numerator. So that gives us 6a times b squared all divided by c squared. All right, so now moving on to expressions that are polynomials. A polynomial is an expression consisting of variables and coefficients, and importantly, it can only involve certain operations. So we have addition, subtraction, multiplication, and non-negative integer exponents. So first we have, and then the degree of a polynomial is the greatest exponent on individual term of the polynomial. So this first example, first we want to determine whether it is a polynomial. So we have 1/4 x cubed plus 3x squared minus 8xy plus 5. So even though we have this xy here, it's still a polynomial. It's not a polynomial with one variable, but notice it still meets all of these conditions: addition, subtraction, multiplication, non-negative integer exponents. And nowhere does it specify that they're going to only be one variable. So yes, it's a polynomial. And the highest exponent we have is x to the third, so it is degree 3. Number 4, we have square root of x minus 2x plus 5. No, it's not a polynomial because of that. We can't have a square root. And the last one, we have x cubed y to the 4th minus 5x to the 5th minus y. So it only has multiplication, integer exponents, addition, and subtraction. So yes, it's a polynomial. And the degree of this polynomial is actually tricky because you have to look at the total degree of the terms. So we have x to the 3rd and y to the 4th. So in total, that's a degree 7 polynomial. Now, that does not mean that you could add those exponents, but for calculating the degree of a polynomial, we're looking at the degree of of an individual term, so we do take both those exponents into account. So it's degree 7 and not degree 5. All right, so moving on to simplifying polynomials. The polynomial expression is in simplest form when all the like terms are combined, there's no parentheses, and we have simplified fractions. So this first example here, we cannot combine the 3x to the 4th and the 2x cubed. So the first step here is going to be to distribute this 3x because that eliminates parentheses for us. So we have 3x to the 4th minus 2x squared, and then minus 15x to the 4th minus 6x cubed and plus 21x. And from here, we just need to combine all like terms. So I start by looking at the term with the highest power. So 3x to the 4th and negative 15x to the 4th combine to make negative 12x to the 4th. The next highest exponent that I have is x cubed. And there are no other cubic terms, so that just stays as negative 6x cubed. Now I'll look at my squared terms. These can also be called quadratic terms. And just in the nick of time, I noticed this should be 21x squared because it was negative 3x times negative 7x. So we have negative 2x squared plus 21x squared gives us plus 19x squared. And that is all of the terms. So we've combined everything, and this is our final answer. It's generally standard to write the terms with decreasing exponents, so x to the 4th, x cubed, x squared. It's certainly not wrong if they're in different orders, because order doesn't matter when you add, subtract, but it's just considered standard. So, on to number 7. So notice this first set of parentheses. There's nothing we can do inside of the parentheses. it's not being multiplied by anything, so it actually becomes irrelevant. We can't combine the terms inside the parentheses, and it's not being, there's no operations outside the parentheses, so we just can ignore it. And the negative 5 we do distribute, so that becomes minus 25x minus 30. And then to combine like terms, there are no other x squared terms. So we have just negative 2x squared. X minus 25x becomes minus 24x and minus 30. So multiplying polynomials, we're going to use the distributive property and then combine like terms. There's really two ways you can do this. Now notice a lot of you are used to using the FOIL method, I'm sure, for multiplying. But that only works if you have polynomials that both have two terms. So notice this, we have a polynomial with 3 terms, or a trinomial. And this has 2 terms, also called a binomial. So we can't use FOIL to multiply these, but we can use a similar technique. Because we're going to multiply each term in the first one by each term in the second one, and then combine all the like terms. So 2a squared times 3a is 6a to the third. 2a squared times negative 1 is minus 2a squared. And then we use the middle term. So negative 5a times 3a is negative 15a squared. And negative 5a times negative 1 is positive 5a. And then we do the last one. 7 times 3a is 21a. And 7 times negative 1 is negative 7. So it's like FOIL, except there's a middle term, and there's not some nice little acronym to remember how to multiply all of them. And now we just need to combine like terms. So there's only one cubic term, so that one can just be brought straight down, 6a to the third. We have 2 quadratic terms, negative 2a squared minus 15a squared, and that is negative 17a squared. And then 5a plus 21a is 26a. And minus 7. So another way that you can multiply polynomials, it's essentially the same thing. You'll get the same result. It's a method I prefer because I think it keeps everything more organized. So we're actually going to line these up vertically. 2y squared plus 6y minus 7 times 5y plus 2. And it looks a lot like the multiplication algorithm you learn in elementary school. So I'm going to multiply 2 times negative 7 and get negative 14. 2 times 6, so just like you were multiplying numbers in elementary school, 2 times 6y is 12y. And 2 times 2y squared is 4y squared. Notice it is important to keep track of the signs. Now I'm going to do the 5y. So 5y times negative 7 is negative 35y. So really what this does for me is it's going to line up my like terms. So because it's a y term, I'm going to write it here. So negative 35y. 5y times 6y is 30y squared. And 5y times 2y is 10y cubed. And this is nice, again, because the like terms are lined up. I don't have to look for them. So negative 14 stays by itself. 12y minus 35y is negative 23y. 4y squared plus 30y squared is 34y squared. And 10y cubed. All right, so the last two examples, essentially the same thing, but now we're calling these things are written as functions. So suppose we have two functions. F of x is 3x squared plus x minus 7, and g of x is 3x squared plus 8. This notation here, f minus g of x, now this is, because these are functions, this is f minus g of x. This is not multiplication, okay? So f minus g of x simply means f of x minus g of x. And we know what those things are. F of x is 3x squared plus x minus 7. And g of x is 3x squared plus 8. And notice it's in parentheses because I want to make sure I subtract the whole thing and not just part of it. So the difference being that this negative needs to distribute to both. So 3x squared plus x minus 7 minus 3x squared minus 8. We have a positive 3x squared and a negative 3x squared. So those simply go to 0. Those are additive inverses, as the grown-ups would say. And negative 7 minus 8 is negative 15. So this is f minus g of x equals x minus 15. And the last one, here we have f times g of x, which again simply means multiply f of x times g of x. So I'm going to use the vertical method on this one. So 3x squared plus x minus 7. And then the other one is, and notice I'm going to line up the 3x squared over here with the other 3x squared. I'm going to leave the middle one blank and then plus 8. This is just to keep track of where terms are. And yeah, it's a positive 8. So, whoops. So, again, 8 times 7 is negative 56. 8 times x is 8x. And 8 times 3x squared is 24x squared. So since there's no middle term here, I'm just going to skip that one and jump straight to 3x squared times negative 7. But because it's going to be an x squared term, I'm going to line it up below 24x squared. So that's negative 21x squared. The whole point of this is just to keep your like terms aligned. So 3x squared times x is 3x cubed, and 3x squared times 3x squared is 9x to the 4th. So here we can see there's only one pair of like terms that we have to add. If we had done this horizontally, then it might be a little trickier because you have to look for those like terms. So negative 56, positive 8x. This is positive 3x squared, positive 3x cubed, and 9x to the fourth. And all of that is equal to f times g of x. All right, so as you can see, sometimes these can get a little bit tricky or a little bit tedious, but overall it's really just more